Hey everyone, in this video we are looking at motion of a vehicle negotiating a corner and where the road is banked at an angle theta. The guiding question is saying a double-deck bus whose wheels are 2.4 meters apart and center of gravity 1.5 meters above the ground is to round a road banked at 10 degrees to the horizontal at 50 kilometers per hour. Calculate the minimum radius of curvature if overturning is not to occur. Take G as 9.81 meters per second squared. Let us look at the solution of this problem. 1. As the bus negotiates this corner that has the radius of curvature R at a speed V equal to 50 kilometers per hour, we know it is going to be acted upon by a number of forces, and the major forces that we consider here is the weight of the body, which is the bus, and the centrifugal force that tries to pull this bus out of the circular motion. Now, if we are to consider stability conditions, then the resultant force of the weight and the centrifugal force must be normal or must be perpendicular to the road at that point where the bus is negotiating the corner. Therefore, since we have velocity as v in kilometers per hour, we have to change it to meters per second. So in 1 kilometer we have 1,000 meters, and in 1 hour we have 3,600 seconds. So if we convert this velocity 50 kilometers per hour, we will have 13.889 meters per second. Therefore, we know that velocity v is equal to square root of rg h minus d out of 2 tan theta divided by d out of 2 plus h tan theta. This is the expression for calculating the maximum velocity of a vehicle negotiating a corner on a banked road if overturning is not occur, or it is that maximum velocity beyond which overturning of the vehicle will have to occur. If it is to occur, then it will be lifted up here and will fall within the corner. So if it is not to occur, the speed of the vehicle should equal to. Should it go beyond that, then we will have issues. If you have not seen how to derive this formula, I will share the link in the description so that you can go and follow it up and see how we derive this expression. Therefore, if I substitute in the information that I have, first of all, I need to square both sides here. If I square here and I square both sides here, this and that will go, so that I have v squared equal to rg h minus d out of 2 tan theta everything over d out of 2 plus h tan theta. So if I substitute in our values, I will have 13.889 squared divided by, it will be divided by, of course, I will make r the subject of the formula, then divided by g, which is 9.81 times the expression which is h minus d out of 2 tan theta, d out of 2 plus h tan theta. If we substitute in the values of h as 1.5, then d as 2.4, then you'll have this expression. So if I substitute in here, R will be 13.889 squared divided by 0.8798 times 9.81, and the radius of curvature, if overturning is not occur, is going to be 22.35 meters.